Hello! I decided to create a short video to explain vector databases which are becoming increasingly popular in IT sector. This video is part of the vector databases series where we provide concise and to-the-point explanations of storage engine, indexing algorithms, built-in similarity metrics, optimizations, downsides and trade-offs, use cases, final thoughts for each database. If any of the terms or explanations are unclear, you can always look them up in the GPT or Google to better understand the fundamentals and principles of specific vector database. The goal of the video is to provide a short and concise covering only of the core concepts. Thank you and enjoy! And like and subscribe. I do need subscribes though. Thank you. Pinecone is a fully managed vector database designed for a fast and scalable similarity search in AI applications. It is particularly optimized for Retrieval-Augmented Generation, Semantic search, and recommendation systems, making it a leading choice for integrating with LLMs, OpenAI, and LangChain. Let's talk about storage engine. Pinecone is built on a hybrid storage architecture combining RAM, SSDs, and distributed cloud storage for efficiency. In Pinecone we have hierarchical memory model. That means frequently accessed data stays in RAM, while less used vectors are pushed to SSD or cold storage. Next we have automatic tiering that moves data between memory and disk based on query frequency to optimize cost. Another storage feature, sparse dense hybrid indexing, allows combining dense vectors with sparse keyword-based data for hybrid search. That is combination between vector search and text metadata filtering. And serverless architecture. Pinecone automatically scales without manual infrastructure management. In conclusion, we can say, unlike Qudent, which is a self-hosted or cloud-based, Pinecone is a fully managed, meaning you don't worry about deployments, indexing, or scaling, it just works. Next topic, indexing algorithms. Pinecone primarily uses hierarchical navigable small world for fast vector search, but enhances it with proprietary optimizations. HNSW is a state-of-the-art algorithm for approximate nearest neighbor search. It builds a multi-layered graph structure where each node connects to its closest neighbors, ensuring fast lookups. Next indexing algorithm is vector compression or product and scalar concatenation, meaning reduces memory footprint while maintaining accuracy. Next algorithm, metadata filtering, meaning allows queries based on additional metadata, enabling hybrid search. And the last one, multi-tenant isolation, meaning ensures different indexes to operate efficiently without interference. In conclusion, we can say Pinecone server power comes from index management automation, dynamic load balancing, and hybrid search capabilities. Let's talk about built-in similarity metrics a little bit. We have Euclidean distance, measures the straight line distance between two vectors in a multidimensional space. It's sensitive to the magnitude of the vectors and is commonly used in applications where the absolute difference between vector components are important. Next, Cosine similarity evaluates the cosine of the angle between two vectors. focusing solely on their direction regardless of magnitude. This metric is often used in scenarios like document similarity and semantic search, where the orientation of the vectors matters more than their length. And dot product calculates the sum of the products of corresponding vector components, considering both magnitude and direction. It's useful in contexts like recommendation systems and ranking tasks and others, where the emphasis is on the combined effect of vector magnitude and their alignment. In conclusion, we can say, when we create an index in Pinecone, you can specify the desired distance metric. It's important to choose a metric that aligns with the training of your embedding model to ensure optimal performance. For instance, if your model was trained using Cosine similarity, it's advisable to use the same metric in your Pinecone index. Now, let's talk about optimizations and benefits. Pinecone provides several key optimizations to make vector search faster and more cost-efficient. First, auto-scaling and serverless. No need to manage infrastructure. Pinecone scales up or down as needed. Second optimization, long-term persistent indexes. Meaning, unlike some in-memory vector databases, Pinecone persists data so you don't lose vectors between restarts. Next, hybrid search allows mixing keyword-based search with vector embeddings, useful for retrieval-augmented generation. Fourth, query caching and load balancing, meaning speeds up repeated searches and distribute workloads efficiently. And fifth, Pinecone provides simple API, no need for complex query tuning, just send a request and Pinecone finds the best match. In conclusion, we can say Pinecone's key advantage is that it removes the need for DevOps. You don't have to worry about managing resources, optimizing indexes, or scaling manually. Pinecone does that for you. Use cases where Pinecone shines. It is a go-to solution for any applications requiring fast, accurate vector search. For example, like Retrieval-Augmented Generation, powering LLMs like ChatGPT to fetch relevant context efficiently. Or another one, like semantic search, finding documents, frequently asked questions, or articles that match a user's intent. Third, product and media recommendation, meaning serving personalized content based on embeddings from user interactions. Next, fraud and anomaly detection, meaning spotting unusual behavior in, for example, finance, cybersecurity, social platforms, and others. And last but not least, generative AI applications, enabling context-aware AI chatbots and personalized assistance. In conclusion, we can say Pinecone is one of the best choices for LLM applications because of its hybrid search, low latency, and scalability. Despite its advantages, Pinecone has a few downsides and trade-offs to consider. For example, it's fully managed, no self-hosting. Unlike Qdant, you cannot self-host Pinecone. You must use their cloud service. Next, higher cost for large datasets, meaning Pinecone's managed pricing can be expensive compared to self-hosted options like Qdant or Weavit. Less customization, no direct access to fine-tuned indexing parameters like HNSW connections. Another downside, limited open source community. Unlike Qdant, there is no open source version, so you are locked into Pinecone's ecosystem. And last, metadata filtering limitations. While metadata filtering exists, it's not as flexible as combining traditional relational queries with embeddings. In conclusion, Pinecone is ideal for teams that want plug-and-play solution, but if you need on-premise hosting, deeper customization, or more control over indexing, Couldn't or Weave might be a better choice. Final thoughts. Pinecone is one of the best choices for enterprise AI teams that want fast, scalable, and maintenance-free vector search. It's particularly strong for LLM-powered applications, semantic search, and recommendation system where scalability and ease of use are the top priorities. However, if self-hosting, cost control, and custom indexing are more important, Couldn't or Weave might be a better choice.